Okay, so let's talk about the future of AI. And I mean the real future. Imagine an AI that doesn't just follow instructions, but can actually reason, create, and adapt just like a human. Today, we're diving into the ultimate frontier, AGI, or Artificial General Intelligence. And believe me, this isn't just some fancy software update. It's a concept that could literally redefine our world. You know, we already live with AI. It's in our phones, it recommends our movies, it navigates our cities. It's basically everywhere. But where is all of this tech actually going? What's the end game? Well, to answer that, we have to understand the huge leap from the AI we know today to what's coming next. So let's start right there. To really get a handle on AGI, you have to see the massive, massive gap between the AI we have now and the AI that researchers are trying to build. We are talking about a fundamental shift, a move from specialized one-trick pony tools to a truly general intellect. This slide breaks it down perfectly. On the left, you've got today's narrow AI. It's a brilliant specialist. I mean, it's a master at recognizing patterns, right? It can spot a tumor in a scan or destroy a grandmaster at chess. But it's brittle. Take it outside of that one specific task and the whole thing just falls apart. Now look to the right. AGI is all about being versatile and having genuine comprehension. It's kind of like the difference between a calculator that can only do math and a mathematician who can invent whole new fields of it. The secret sauce here, the thing that makes AGI so different, is what we call cognitive plasticity. An AGI with this ability wouldn't just freeze up when you take it out of its comfort zone. It could, in theory, learn to play a new instrument, get the subtle meaning of a joke, or solve a physics problem it's never, ever seen before. And it would do it by applying logic and reason, not just by spitting out data it was trained on. So the billion-dollar question is, how in the world do you actually build one? Well, researchers think the blueprint for a real thinking machine rests on a few key pillars. These are the absolute non-negotiables for any system that's going to truly think, reason, and adapt on its own. Okay, so to build an AGI, the focus is on these four core ideas. First up, contextual transfer. This means an AI could learn about fluid dynamics in a simulation and then turn around and use that knowledge to design a better airplane wing in the real world. Second, autonomous goal setting. So instead of waiting for you to tell it what to do, it would spot a problem, like a traffic jam, and just start figuring out solutions on its own. Third, reasoning from first principles. This is huge. It wouldn't just copy what's been done before, it would build new solutions from the ground up, based on the fundamental laws of physics or logic. And finally, sensory integration, mixing video, audio, and all sorts of other data into one single cohesive model of reality, just like our brains do. And let me tell you, each one of these is a monumental challenge all by itself. As you can probably guess, the path to building an artificial mind is just littered with massive, massive hurdles. This isn't just a simple engineering problem. We're talking about a fundamental science problem. So let's get into the two biggest roadblocks that researchers are dealing with right now. First up, the data problem. And this is a big one. Think about it. A little kid can learn what a cat is after seeing maybe one or two of them. But today's deep learning models, they need to be fed millions, literally millions, of labeled cat pictures to get the same result. They are incredibly data hungry. So bridging this massive efficiency gap is one of the top priorities. Yeah, the holy grail here is to find an algorithm that can learn more like we do, not through brute force repetition, but through real observation, curiosity, and just plain old logical deduction. That's a completely different way of learning. The second roadblock is power. And this number is just mind-blowing. The human brain, right, the most complex thing we know of in the entire universe, performs trillions of calculations every second, and it runs on just 20 watts of power. That is less than a dim light bulb. Just let that sink in. Now compare that to our very best technology. A modern supercomputer that tries to simulate even a tiny fraction of what the brain does can require its own dedicated power plant. The energy gap isn't just big, it's absolutely astronomical. So what's the solution? Well, the most promising idea might actually be a hardware revolution. It's a field called neuromorphic computing. The whole goal is to build microchips that are designed like a brain, copying the physical structure and hopefully the incredible efficiency of our own neurons. So let's say we do it. We overcome these colossal hurdles. What happens then? Well, the arrival of AGI won't just be another cool tech breakthrough. No, it's going to be society's ultimate test, fundamentally reshaping civilization as we know it. The Industrial Revolution automated physical labor, right? Well, the AI revolution is poised to automate cognitive labor. And we're not talking about factory assembly lines here. We're talking about the work done by scientists, financial strategists, lawyers, maybe even artists. This puts humanity at a pretty monumental crossroads. I mean, on one hand, you have the potential for a post-scarcity world, a utopia where expert medical advice or a brilliant scientific discovery costs next to nothing. But on the other hand, it forces us to completely rethink what work even means. and to figure out how we distribute resources when human brainpower is no longer the main economic driver. And that brings us to what is, without a doubt, the single most important question in this entire field. With a technology this powerful, how do we guarantee, not just hope, but guarantee that it stays safe and beneficial for every single one of us? This is famously known as the alignment problem. It's the challenge of making absolutely sure that an AGI's goals and values are perfectly aligned with our own. Because with a system that can improve itself at lightning speed, even a tiny little misunderstanding of its main goal could spiral into some really catastrophic unintended consequences. The main strategy being worked on here is called safety by design, and this isn't about just tacking on some safety rules at the end. No, it's about weaving core human values, things like compassion and cooperation, into the AGI's learning process from the very beginning, making those values a core, inseparable part of its intelligence. So, the big question everybody asks, when can we expect this future? Well, the honest answer is nobody really knows. You've got some industry leaders predicting AGI could be here as early as 2030, but then you have a lot of academic researchers who think we're still decades away from the big breakthroughs we need. The only real consensus is there is no consensus. And another question that always comes up is, will it be conscious? Will it have feelings? It's really important to separate intelligence from consciousness. A system can be a brilliant, superhuman problem solver without actually being sentient or having any kind of inner experience. Whether consciousness just pops up from enough intelligence, or if it's something else entirely, well, that's one of the biggest philosophical debates of our time. In the end, this whole massive quest is about so much more than just building better algorithms. As this quote puts it so perfectly, it really is an exploration of the nature of thought itself. In our attempt to create an artificial mind, we're being forced to understand our own minds in ways we never have before, pushing the boundaries of what's possible for both us and for the machines we create.